NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math lesson on factoring quadratic trinomials. Today, we'll learn how to factor expressions like x squared plus 4x plus 3 using the sum and product method. Before we dive into specific examples, let's understand the general pattern. When we have a quadratic trinomial in the form x squared plus bx plus c, we're looking to factor it into the form x plus p times x plus q, where p and q are numbers whose sum equals b and whose product equals c. Let's look at the standard factoring pattern for a trinomial. When we have x squared plus the sum of a and b times x plus the product of a and b, this factors as x plus a times x plus b. Let's start with our first example. We have x squared plus 4x plus 3. For this trinomial, we need to find two numbers that multiply to give us 3 and add up to give us 4. Let's list the factor pairs of 3, 1 and 3. Since 1 plus 3 equals 4, these are the numbers we're looking for. So our numbers are 1 and 3. We can rewrite our expression as x squared plus 1x plus 3x plus 3. This allows us to factor by grouping x times x plus 1 plus 3 times x plus 1. This gives us x plus 1 times x plus 3. Let's move to our second example, x squared plus x minus 2. For this trinomial, we need to find two numbers that multiply to give us negative 2 and add up to give us positive 1. The factor pairs of negative 2 are negative 1 and 2, or 1 and negative 2. Since negative 1 plus 2 equals 1, these are our numbers. So our numbers are negative 1 and 2. We can rewrite our expression as x squared minus 1x plus 2x minus 2, factoring by grouping x times x minus 1 plus 2 times x minus 1. This gives us x minus 1 times x plus 2. For our final example, let's factor x squared plus 2x minus 15. For this trinomial, we need to find two numbers that multiply to give us negative 15 and add up to give us positive 2. Let's list the factor pairs of negative 15, negative 1 and 15, 1 and negative 15, negative 3 and 5, and 3 and negative 5. Since negative 3 plus 5 equals 2, these are the numbers we're looking for. So our numbers are negative 3 and 5. We can rewrite our expression as x squared minus 3x plus 5x minus 15. Factoring by grouping x times x minus 3 plus 5 times x minus 3. This gives us x minus 3 times x plus 5. Let's summarize what we've learned about factoring quadratic trinomials using the sum and product method. First, identify the coefficients b and c in the standard form x squared plus bx plus c. Next, find two numbers p and q such that p plus q equals b and p times q equals c. Finally, write the factored form as x plus p times x plus q. We saw how this works with three examples: x squared plus 4x plus 3 equals x plus 1 times x plus 3, x squared plus x minus 2 equals x minus 1 times x plus 2, x squared plus 2x minus 15 equals x minus 3 times x plus 5. With practice, you'll be able to factor quadratic trinomials quickly and accurately. We have x squared plus 10x plus 24. To factor this expression, we need to find two numbers that multiply to give 24 and add up to give 10. Let's list some factor pairs of 24 and see which pair adds up to 10. The factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now, let's check which pair adds up to 10. 1 plus 24 equals 25, too large. 2 plus 12 equals 14, still too large. 3 plus 8 equals 11, getting closer. 4 plus 6 equals 10. That's it. We need the factors 4 and 6. So we can rewrite our expression as x squared plus 6x plus 4x plus 24. We're splitting the middle term 10x into 6x plus 4x based on the factors we found. Next, we can factor by grouping. We'll take out common factors from each pair of terms. From the first two terms, we can factor out an x, and from the last two terms, we can factor out a 4. Notice that we have a common factor of x plus 6 in both terms. So we can factor that out to get x plus 6 times x plus 4, which is our final answer. Let's verify this is correct by multiplying these factors. Let's try another example. This time, we have x squared minus 7x minus 60. The process is similar, but we need to be careful with the signs. We need to find two numbers that multiply to give negative 60 and add up to give negative 7. Let's list the factors of 60. The factors are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Since our constant term is negative, we need one positive and one negative factor that multiply to give negative 60. We also need them to add up to negative 7, which means the negative factor must have a larger absolute value than the positive factor. So we need the factors 5 and negative 12, which multiply to negative 60 and add up to negative 7. We can rewrite our expression as x squared plus 5x minus 12x minus 60. Now, we'll factor by grouping. From the first two terms, we can factor out an x, and from the last two terms, we can factor out negative 12. We can now factor out the common factor x plus 5. So our final factored form is x plus 5 times x minus 12. Let's move on to a more challenging example. Now we have 4x squared minus 20x plus 21. This is a bit more complex because the coefficient of x squared is not 1. We need to use a slightly modified approach. For trinomials in the form ax squared plus bx plus c, whereas not 1, we need to find factors of a times c that sum to b. In our case, a equals 4 and c equals 21, so a times c equals 84. And b is negative 20, so we need to find two numbers that multiply to give 84 and add up to negative 20. Let's check some factors of 84. The factors of 84 include 1 and 84, 2 and 42, 3 and 28, 4 and 21, 6 and 14, 7 and 12. Since we need a sum of negative 20, both factors should be negative. Negative 6 and negative 14 add up to negative 20, and they multiply to give 84. So these are our factors. Now, we'll rewrite the middle term using these factors. We'll split negative 20x into negative 6x minus 14x. Next, we'll factor by grouping. From the first two terms, we can factor out 2x, and from the last two terms, we can factor out negative 7. We now have a common factor of 2x minus 3. So our factored form is 2x minus 3 times 2x minus 7. Let's look at one more example. We have x squared minus 6x plus 8. Since the coefficient of x squared is 1, we'll use our original approach. We need to find two numbers that multiply to give 8 and add up to negative 6. The factors of 8 are 1 and 8, 2 and 4. Since the constant term is positive, but the coefficient of x is negative, we need both factors to be negative. Negative 2 and negative 4 multiply to give positive 8, and they add up to negative 6. These are our factors. Instead of going through all the factoring steps again, we can directly write the factored form as x minus 2 times x minus 4. Let's verify this by multiplying the factors. Let's summarize what we've learned about factoring quadratic trinomials. When the leading coefficient is 1, as in the form x squared plus bx plus c, we find two numbers that multiply to give c and add up to give b. When the leading coefficient is not 1, as in the form ax squared plus bx plus c, we find two numbers that multiply to give a times c and add up to give b. Then we split the middle term, factor by grouping, and simplify to get the factored form. This technique works for a wide range of quadratic expressions. Let's look at an example. We want to factor the polynomial x to the fourth plus x squared minus 2. First, let's observe that x squared appears in the expression. We can think of this as a substitution problem, where we let u equal x squared. Then our expression becomes u squared plus u minus 2. Now that we have a quadratic expression in terms of u, we can factor it using standard quadratic factoring techniques. The expression u squared plus u minus 2 can be rewritten as u squared plus 2u minus u minus 2. Now, we need to substitute x squared back for u. This gives us the expression x squared plus 2 times x squared minus 1. We can factor the term x squared minus 1 further as the difference of squares. We know that x squared minus 1 can be written as x minus 1 times x plus 1. So our final factored form of the original expression x to the fourth plus x squared minus 2 is x squared plus 2 times x minus 1 times x plus 1. Let's start with our first example. We want to factor the quadratic expression x squared minus 10x plus 24. To factor this expression, we need to find two numbers that multiply to give 24 and add up to negative 10. Let me show you how to approach this systematically. We need the sum to be negative 10, but all these pairs give positive sums. Since we need a negative sum, we should consider negative factors. Since 24 is positive, both factors need to be negative to give a positive product. Great! We found that negative 4 and negative 6 multiply to give 24 and add to negative 10. Let's use this to factor our expression. Now we can rewrite this as a product of two binomials. We'll have x plus negative 4 times x plus negative 6, which simplifies to x minus 4 times x minus 6. Let's verify our factorization by multiplying these factors to make sure we get back our original expression. Let's look at our second example, x squared plus 5x plus 1. Let's see if we can factor this quadratic expression. For this quadratic, we need to find two numbers that multiply to give 1 and add up to 5. Let's list the factors of 1. The only factors of 1 are 1 and 1, but they sum to 2, not 5. Let's also check with negative factors. Since 1 is positive, we would need one positive and one negative factor with a larger absolute value on the negative side. As we can see, the possible factor pairs for 1 cannot sum to 5. We would need irrational numbers to factor this expression. In the original text, which was in Persian, it was stated that we cannot find two numbers whose sum is 5 and product is 1. We need to factor the expression 3x to the fourth power minus 3x cubed minus 36x squared. The first step when factoring polynomials is to look for a common factor that appears in all terms. In this case, we can see that 3x squared is a factor of each term in our expression. Let's factor it out. Now we have 3x squared times the trinomial x squared minus x minus 12. Let's focus on factoring this trinomial. We need to find two numbers whose product is negative 12 and whose sum is negative 1. Let's try different pairs of factors of negative 12 and see which pair gives us a sum of negative 1. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Since we need a negative product, one of the factors must be negative. Let's check each pair. 1 and negative 12. Sum is negative 11. Negative 1 and 12. Sum is 11. 2 and negative 6. Sum is negative 4. Negative 2 and 6. Sum is 4. 3 and negative 4. Sum is negative 1. Negative 3 and 4. Sum is 1. We found our pair. 3 and negative 4 have a product of negative 12 and a sum of negative 1. Now we can rewrite our trinomial using these factors. X squared minus x minus 12 equals x squared plus 3x minus 4x minus 12. This can be factored as x times x plus 3 minus 4 times x plus 3, which simplifies to x plus 3 times x minus 4. Substituting this back into our original expression, we get 3x squared times x plus 3 times x minus 4, which gives us the fully factored form. 3x squared times open parenthesis x plus 3 close parenthesis times open parenthesis x minus 4 close parenthesis. Let's move on to our second example. We need to factor the expression x to the fourth power plus x squared minus 20. For this example, there's no common factor to factor out. However, we can use a substitution method. Let's denote u equals x squared. Then our expression becomes u squared plus u minus 20. Now we can factor this quadratic. We need to find two numbers whose product is negative 20 and whose sum is 1. Let's check some factor pairs. 1 and negative 20, sum is negative 19. Negative 1 and 20, sum is 19. 2 and negative 10, sum is negative 8. Negative 2 and 10, sum is 8. 4 and negative 5, sum is negative 1. Negative 4 and 5, sum is 1. We found our pair. Negative 4 and 5 have a product of negative 20 and a sum of 1. Now we can factor our quadratic expression. U squared plus u minus 20 equals u squared minus 4, u plus 5 u minus 20, which factors as u times u minus 4 plus 5 times u minus 4, which simplifies to u minus 4 times u plus 5. Now, we substitute back our original variable. Since u equals x squared, we get x squared minus 4 times x squared plus 5, which is x squared minus 4 times x squared plus 5. We can factor x squared minus 4 further. This is a difference of squares. X squared minus 4 equals x squared minus 2 squared, which factors as x minus 2 times x plus 2. Substituting this back, we get x to the 4th power plus x squared minus 20 equals x minus 2 times x plus 2 times x squared plus 5. This is our fully factored form. Let's summarize what we've learned about factoring polynomials. First, always look for a common factor and factor it out. Second, identify the structure of the remaining expression and use appropriate factoring techniques such as factoring trinomials or using substitution. Third, continue factoring until you can't factor anymore. And lastly, check your work by multiplying the factors to ensure you get the original expression. We're going to factorize the expression x squared minus the quantity a plus b times x plus ab. Let's first understand what this means. Let's start by rewriting our expression to make it clearer. X squared minus the quantity a plus b times x plus ab can be rewritten as x squared plus negative a plus negative b times x plus ab. We're using the distributive property to expand negative a plus b times x. In step 2, let's rewrite this further by grouping the terms differently. We can rewrite the expression as x squared plus the sum of negative a and negative b times x plus the product of negative a and negative b. Here, we're looking for a pattern where we have a perfect square, trinomial, or a product of two binomials. We're trying to express our second term as the sum of two values and our third term as the product of those same values. In our final step, we recognize that we can factor this expression into a product. We get the expression equals the quantity x minus a times the quantity x minus b. This factorization works because when we multiply these factors and expand, we get back our original expression. The pattern we're using is that if we have x squared plus the sum of p and q times x plus p times q, this can be factored as the product of x plus p and x plus q. Let's recap what we did. We took the expression x squared minus the quantity a plus b times x plus ab, identified the pattern, and factored it into the product of x minus a and x minus b. Now, let's look at our second example. In this example, we'll factorize the expression x squared plus 8x plus 15. For the middle term 8x, we need to find two numbers that add up to 8. Let's rewrite 8x as 3x plus 5x. Let's expand this further by showing that 3 and 5 are the numbers we need. 3 plus 5 equals 8, and 3 times 5 equals 15. So we can rewrite our expression as x squared plus 3x plus 5x plus 15. Finally, we can factor this expression into a product. We get x plus 3 times x plus 5. Let's recap this example. We factorized x squared plus 8x plus 15 by finding the numbers 3 and 5, which add up to 8, and multiply to give 15. This allowed us to factor the expression as x plus 3 times x plus 5. Now, let's move on to our third example. In our final example, we'll factorize the expression x squared plus x plus 1/4. This is a special case where we have a perfect square trinomial. Let's identify the pattern. Looking at this expression, we need to find two numbers that add up to 1 and multiply to give 1/4. Let's rewrite the middle term as 1/2 plus 1/2. Let's verify that 1/2 and 1/2 work. 1/2 plus 1/2 equals 1, and 1/2 times 1/2 equals 1/4. So we can rewrite our expression as x squared plus 1/2 x plus 1/2 x plus 1/4. Now, we can factor this expression. First, we get x plus 1/2 times x plus 1/2. This can be simplified further as the square of the quantity x plus 1/2. Let's recap this final example. We factorized x squared plus x plus 1/4 by recognizing that it's a perfect square trinomial. We identified that the middle term could be split as 1/2 plus 1/2, and the last term is the square of 1/2. This allowed us to factor the expression as the square of x plus 1/2. To summarize what we've learned about factorizing quadratic expressions, first, identify the pattern in your quadratic expression. For expressions in the form x squared plus, sometimes x plus product, factor as x plus p times x plus q, where p plus q equals sum and p times q equals product. For perfect square trinomials in the form x squared plus 2bx plus b squared, factor as the square of x plus b. Remember to look for patterns and relationships between the coefficients to find the correct factorization. Practice these techniques with more examples to build your factorization skills. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.